Okay, when we concluded, we talked about how we could, how these prices were measured in units of, well, how the units of QT0 ST were sort of arbitrary, and how we could normalize, we could, if QT0 ST, that whole system is a competitive equilibrium price system, then by multiplying all prices by the same scalar, we still have a competitive equilibrium price. So the price level is indeterminate. And we can normalize in a variety of ways. Sometimes normalization is taken so the units are, sometimes the units are time 0 state S0 consumption goods. That's one normalization that's often used, but there are others. So now we calculated. I want to consider when you have a situation when we want to compute the price of a. Well, remember we had a formula like this. We had a price of a tail asset. So that we were pricing at time tau greater than 0 and some particular history. We had this formula. We computed it, p tau of p tau at tau of S tau. Well, we originally computed it like this. So let's just remember our formula. We summed over t greater than or equal to tau, because that's when we're going to get paid off. We summed over ST's future histories, starting from S tau, and then we used our original prices, and we got our payoff. But our payoff is only going to occur for dates t greater than or equal to tau, and only for histories ST that start from S tau. And then we said, well, it will change units of this. And we could change units like this. P tau, I want to change to units not of time 0 consumption good, but time tau consumption goods. And to do that, I'm just gonna take p tau 0 of S tau, what I had up there, and I'm going to divide by QT 0 of S tau. I'm just going to renormalize the prices. And if I do that, I'll just do that up here. Just do that, do it in red to have fun. QT 0 S tau, I'll do that. And then I'll do the same thing here. S tau, I'll do that. So that's what I'm going to do. And I'm going to define this thing. I'm going to define this thing as Q tau tau S T. That's my new price system. I'm going to start from tau, and I'm going to start from S tau. And that's going to be used to price claims that pay off at dates greater than or equal to tau. And if we just compute this, let's compute this, because we'll get an expression that you see a lot in finance. Compute this, Q tau 0 S tau, and we'll just do our formulas. That's beta to the t, u prime CTI for any I, ST, and then we have our pi t, our joint density over that. And I'm going to divide that by beta to the tau. I just copy u prime c what's in here, tau I s tau, because I'm just substituting for this, pi tau of S tau. That's just copying. And what I mean by copying is the numerator is equal to that, the denominator is equal to that, from our formulas for the Error-Debreu price system. Has to be that. We got that from the first order condition for the consumer's problem. So then, so that now what we can notice is that that's just a conditional probability, pi t condition on S tau. That's from the laws of conditional probability. Okay, so the final formula that we get, it's a nice formula. We're going to get this formula. So this is equal to beta to the t minus tau, u prime ct I st, u prime c tau I s tau times the conditional probability of moving of this history, given that we've started from this history. So this is our formula for, we'll call this thing Q t starting from tau s superscript t. So that's our formula. And we'll use this kind of kernel price system for pricing tail assets. And we're going to use tail assets as we transit from the Arrow-Debreu economy to an economy in which we do sequential trading. And that's what we're going to move on to next. Okay. So the idea, we can kind of sketch the idea of, we're going to move on to, so you can think of us starting brand new. But when I give you problems to work, I don't want you to think of starting brand new, because there's going to be connections between the Arrow-Debreu economy and the economy with Arrow securities that should be taken advantage when you're actually solving problems and doing computations. I'll just issue that advice. Okay, so you remember we had this picture of a Arrow-Debreu economy with where Estes had two states that was branching out like this. And it was branching out like this, branching out like forever. Okay, and at time zero, commodities were traded. What commodities were traded? Well, at time zero, commodities are traded contingent on this node, this node, this node, this node, all times, all histories. And they're all traded just at once. So at time zero, they're traded. And then how does life unfold? Well, what actually happens is, we started here. We go from here to, I don't know, I want some fancy color. We started here. We ended up here. Then we ended up here. Then we ended up here. And as we go through the tree, maybe we end up here. Maybe we end up here. Then we end up here. We end up here. So we only follow one path through the tree. So the other paths, the contingencies didn't occur. So, we bought fire insurance, but our house didn't burn down. And so on. So, nevertheless, at time zero in the Arrow-Debreu framework, we trade all of these commodities once and for all, and we never trade again. Okay. Now, here's a question. Well, it's tempting to say is, well, wait a minute. What would happen if at this node right here, you suddenly reopened markets and allowed people to trade? What are the consequences of that? So if you do that in the way that Arrow and Debreu envisioned, nothing would happen. Arrow and Debreu claim that nothing would then happen. This requires some thought. And I want you to think about it, and we're going to come back and think about it together later. We're going to have to. So after that little digression, Arrow stared at this and he came up with the following scheme. Suppose he could replace that tree, and at time zero, you're here, and what you do is you trade only one period securities, contingent on being here or here, only one period state contingent securities. And then let's say we go here, and once we get here, we trade only one period securities here. Once we get here, we trade only 1 period securities here. So what we're going to do, what Arrow's vision is, what we're going to do is we're going to trade a smaller number of securities every period. That was his idea. And the trading arrangement, it's still going to be a competitive equilibrium with more frequent trades of fewer securities. See, at time 0, you were trading only, in this setting, 2 securities, two securities because there were only 2 states next period. You only traded 2. But you also traded 4 2-period securities, and you traded 8 3-period securities, and so on. You traded all those simultaneously in one consolidated. And Arrow's beautiful conjecture was actually he could tell you how to achieve the same equilibrium allocation by trading far fewer securities. Okay. And his insight is related to my question here is, what would happen if you reopen markets in a particular way? So that's how we're going to see if these things are tied together. Okay. So one of the themes of modern macro and modern dynamic economics is finding the state is an art. Is an art. So my friend Fernando Alvarez at Chicago says that all the time. And that's part and parcel of the process of Bellmanizing yourself. Taking a problem that might not look recursive at first, but then if possible, finding a way of expressing a state variable so that you can make it recursive in the sense of Bellman. So here, the key to traveling Arrow's journey from Arrow Debreu to Arrow Securities is to find the right state. And as we do that, we're going to get an answer to this question: what would happen if you reopen markets in the Arrow Debreu setting? And you will find what they meant by saying nothing will happen. So this is all tied together. This may be somewhat mysterious because I'm putting a bunch of things on the table simultaneously before resolving them. Okay, so I can tell you the answer here is we're going to have to find, to make Arrow's project work, we have to construct an endogenous state variable. Okay. To give to each agent at a node, we'll call it a node T ST. So again, as our agent goes through life, he or she is going to get to this node and have a particular state variable that that constrains their opportunities. Okay. Okay. So here's going to be the key. Endogenous state variable. It's going to be financial wealth. And the way to get this is we're going to start, we're going to ask, what is the financial wealth at TST in an Arrow-Debreu competitive equilibrium? What is person I's quote unquote financial wealth? And I'm going to write down a definition. I'm going to call it this thing. Your name is I. That's your date. That's the history. And I'm going to write this down. I'm going to go start today and go on forever. I'm going to start from today and go on forever with all possible histories. I'm going to use the price system that we've normalized for date tau. I mean, dyslexia attack. What I mean is I'm going to, my date T, I'm going to start today, and these are my tomorrows. Those are my future possible histories. And now, this is going to be this object, which we computed in the original Arrow-Debreu competitive equilibrium. So let's stare at this. Okay. Well, if I multiply, let's stare at this. And this object is, that's my original, my consumption plan, my competitive equilibrium consumption plan in Arrow-Debreu equilibrium. We know how we got that. But this is just the tail of it. I'm going to start from tau greater than or equal to t. That's what we're doing here. So this is the tail of my consumption plan. What this is that's the tail of my endowment. So this is the excess of the present value of my consumption plan in the Arrow-Debreu equilibrium over the value of the tail asset, which is just my endowment. So if this is positive, let's say this whole thing is, what does it mean if this is positive? If I have wealth at that node, it means that in the original plan, I I purchased claims on consumption by selling claims on consumption earlier. And if this is negative, it means that just the opposite. So if we applied this to notice that here's an exercise. At t equals 0, S0, that's where we start with. What is SAO? What is it? What is it? And you'll see right away, if you apply that and think about definition, this is equal to 0 for all I, because that just becomes the equation SAO 0 I S0 equal to 0 is the budget constraint. In the Arrow-Debreu competitive equilibrium for agent I. Okay? But in a competitive equilibrium, this object said Ti of St does not equal 0 necessarily. But let's stare at this. But something else has to be true. If we just stare at this. But this has to be true. Look at this. If I sum this across all I, that has to be 0. That just becomes the feasibility constraint. Okay. So, I don't know this for a fact, but I can imagine, not too far-fetched, that what we're doing together is we're walking Arrow's steps in how he was sitting in a coffee shop or thinking about how he could support the same equilibrium allocation that he got with Arrow-Debreu with time 0 time trading, with just more frequent trading of a much smaller number of securities. Scratching his head. And to do that, probably starting with the Arrow-Debreu economy and writing some things down. Very similar to what we're writing down, even if it's not in the published paper. Okay, so we've got this kind of continuation wealth that the if psi ti is positive, it means that the person is basically saved, and he's in previous periods he's consumed less than his endowment in a sufficient number of states to accumulate these claims on future consumption that exceed the tail of his endowment. That's the idea. Okay. So it's going to turn out that to Bellmanize this problem, to Bellmanize things, this is the key state variable. Okay. Okay. I'm going to kind of give you a hint. Realizing that in our Arrow-Debreu economy, at each t, st, there is a collection of, I'll write this down, I, T, S, T, I equals, for everybody in our economy, that satisfies this, is the key to proving that if we reopen markets at T, ST, and let people trade at the price. Now our price system is going to be QT tau S tau. We let them trade at that, starting from ST. Then no person will want to change the original plan, CTI ST, from the original Arrow-Debreu time zero equilibrium allocation. If you reopen markets, there'll be no trades. And the key thing is we're going to reopen markets, but now now the budget constraints that the time t, this is, we're now going to convert this to a, let's say this will now become this equation is the start, the budget constraint. The budget constraint will be a version of this where I'll just copy this. If I just copy this and I replace this with some alternative path, so you can pick an alternative path, but it still has to satisfy this. But now the budget constraint's not zero. It's this number that we pre-computed from the Arrow-Debreu competitive equilibrium. I'll ask you if you want to deviate. You can make trades at the competitive equilibrium prices that I'm guessing. I'm guessing these are the new competitive equilibrium prices, these. But your budget, your initial time t wealth is not zero as it was originally. It's this thing, which may be negative or positive. And if you check that out, get the first order conditions, you'll see that they're satisfied only when we have equality there. That's kind of a sketch of how you do that. So that's how these things tie together. Okay. So we've kind of gone around a big circle where we've got this continuation wealth, financial wealth that we've defined. So this bears some thinking about, and I'll just stop now for a minute, for a while. I mean, thanks.